minutes. Okay, so when you're asking about a bottleneck and your throughput is measured in units per time, you're looking for the lowest amount, okay? If you're asked about a bottleneck and you're talking about takt time or time per unit, are you looking for the lowest number or the highest number? Highest number, right? So when you're asked about the bottleneck, one of the errors that I've had students make in the past is they want to go with one side of that equation or the other, and it depends on what you're looking at. Are you looking at throughput or are you looking at takt time? Okay, and takt time represents the average activity time at each workstation. Okay. Activities within a process are performed by basically capital and labor resources. So each activity can require more than one resource, right? And each resource may be allocated to one or more activities. So let's look at an example of that. So we're talking about resources and activities. So if you're talking about making bread, your activities can include mixing the ingredients, kneading the dough, forming the loaves, placing them in the oven, and baking them. Okay? So if we think about those activities, then what resources do we need for that? Okay? A given resource, for instance, a baker, may be used by several of those activities. They can mix, knead, and form the dough, right? Similarly, a given activity, such as loading the oven, may require multiple resources. You need a baker to put it in the oven, and you need the oven, which is a capital resource, right? So a resource pool is a collection of interchangeable resources that can perform an identical set of activities. So you can have labor resources and labor resource pools, and you can have capital resources and capital resource pools, okay? And each unit in a resource pool is called a resource unit. So just some terminology that we're working with, okay? So this example that we're going to talk about, we're going to continue with the bread maker. So let's say that you have 3 flexible bread makers, each of whom can perform any baking activity. They would be viewed collectively as one resource pool with 3 resource units. Okay? In comparison, if each of the 3 bakers were specialized in a separate activity, one mixes, kneads, and forms the dough, respectively, they'd be regarded as 3 resource pools with 1 resource unit each. Do you see the difference? Okay? So if they're interchangeable, you say they're all part of the same resource pool. If they have select activities that they do, you say, okay, well then they're in their own resource pool. Okay? So today's lecture is kind of about just hitting the terminology and making sure that you have a good understanding of resource units, resource pools. Okay? So resource pooling is just combining separate resource pools into a single, more flexible pool that's able to perform several activities. Okay? So we've hit the terminology. We have resource units and we have resource pools. Okay? And we're going to use those when we start to talk about effective capacity. Okay? So when we look at the effective capacity of our process, we're talking about the unit load of a resource unit. So a resource unit is one resource, right? So it's the average amount of time required by the resource unit to process one flow unit, given the way the resource is utilized in the process. So effective capacity of a resource unit is the inverse of the unit load, right? And represents the maximum sustainable flow rate through the resource unit. So what we're saying is that if we have our, well, let's just keep moving and I'll show it to you in an example. Okay? So the effective capacity of a resource pool is the sum of the effective capacities of all the resource units in that pool. So let's look at an example. If our resource unit is an insurance agent and our flow unit is a filed residential insurance claim, assume that on average the agent spends 12 minutes per claim. Okay? Throughput, unit load, right? Minutes per claim, right? Nope, sorry, other way around. So we're talking about a takt time here. That's how long he spends on it, time per unit. Therefore, the effective capacity of the resource unit is the inverse of the unit load. So it's 1 over the unit load. So if our unit load is 12 minutes per claim, then you would say that the effective capacity of that resource unit is 1 per 12 minutes per claim. Okay? And then you're going to turn around and you're going to say, that doesn't make a lot of sense to me, so I'm going to convert that into how many claims they can work on per hour. So I'm going to take 60 minutes per hour times 1 over 12 minutes per claim. and it comes back at 5 claims per hour. Okay? I typically, and I'll show you this setup, and I would encourage you to do the same. These problems all start off in the same way. And they're all going to start off with a unit load that you need to convert into effective capacity. And so I put the unit load in this column, and in the next column I calculate the inverse of that to get the effective capacity of that resource. Okay? And then I continue, each column has a meaning. Okay? And so we'll take a look at that. So the effective capacity of the resource pool then is, okay, well now on the last slide we calculated the effective capacity of that one resource, which was 5 claims per hour. Well then I know if I've got 3 resources, right, then that means I can do 15 claims per hour. Common sense tells you that. This is just telling you that in a formula. So basically what you're going to do is you're going to take the effective capacity of the resource pool and multiply it by the number of resources that you have. Okay? So T sub I is a unit load at a resource pool. C sub I is the number of resource units. Okay? No process can produce output any faster than its bottleneck. The bottleneck is the slowest resource pool of the process. Slowest meaning we were talking about time, right? All right? Thus, effective capacity of a process is the effective capacity of the bottleneck. Okay, so you can't move any faster than the bottleneck of your process. Okay, so here's how I like to set them up. So here's our example 5.1 from the textbook, and let me go ahead and read you the kind of the setup on that.
You go back for like 2 seconds.
Sure.
Okay.
Okay, so example 5.1 says, health maintenance organizations provide their customers with all-inclusive medical service for a fixed monthly fee. To secure services, they contract with physicians and hospitals that provide their services on a fee-per-service basis. When members of an HMO receive medical service, the providing physician or hospital submits a claim to the HMO for reimbursement. New Life Finance is a service provider to HMOs. For a small fee, it performs the entire claims processing operation on behalf of the HMO. Okay, so processing a physician claim consists of the following steps, or the following operations. Claims billed by physicians arrive by mail and are opened and date stamped by the mailroom clerk. Okay, so as you're reading through that, you're thinking, okay, well, we have a resource of a mailroom clerk. Okay. Data entry clerks, there's another resource, a labor resource, right? Enter date stamped applications first in, first out into New Life's claims processing system. Data entry clerks must check claims for proper formatting and completeness of data fields before they input claims into the system. If a claim is not legible, fully completed, or properly formatted, it must be sent back to the physician for resubmission. Once entered, claims are stored in a processing inventory called suspended claims. Step 3. Claims are assigned to a claim processor for initial processing. Step 4. Processed claims are transferred by the system to a claim supervisor for inspection and possible alterations. 5. Claims are returned to their original claim processors who complete the transaction and issue instructions to accounts payable. Okay, so they've described this whole process, and out of that we recognize that we've got these 4 labor resources. So we've got mailroom clerk, data entry clerk, claims processor, and claims supervisor. Okay. So the process involved 5 steps performed by these 4 resource pools. So they've given us, if you look here, we know that this is our unit load, right? So it's our time per flow unit. So the mailroom clerk spends 1 minute on it, right? The data entry clerk spends 5 minutes on it. The claims processor spends 8 minutes on it, and the claims supervisor spends 2.5 minutes on it. Okay, so this is my table of how I set it up in Excel, and then I turn around and I say, okay, well, to get my effective capacity of that resource unit, to convert that into claims per minute, it's the inverse of this. So 1 over 1 is 1, 1 over 5 is 0.2, 1 over 8 is 0.13, 1 over 2.5 is 0.4. That's all that is just the inverse, okay? So you're given this in the problem, you take the inverse of it, and then you're given how many resource units you have in that pool, okay? So we know that we have 1 mailroom clerk, we have 8 data entry clerks, we have 12 claims processors, and we have to have 5 claims supervisors. So I'm interested in how many claims per minute can that resource pool do. All I need to do is take Okay, 1 claim per minute times 1 resource. We can do 1 right per minute. Okay, 0.2 times 8 gives me 1.6. 0.13 times 12 gives me 1.5. 0.4 times 5 gives me 2. Right? And so it's not a hard setup, but you just have to format it in your head to go, this is what I'm doing with these things. Okay? If you try to, again, I think if you don't organize it that way, you get lost in the shuffle. And this is a very simple way to just organize it and step through it. Okay? So where's the bottleneck in this process? Zach, what am I looking for the bottleneck?
Are you comparing the unit load and the effective capacity?
I'm coming out here. So the bottleneck of this process, right? We would come out to the end of the day to say, how many claims per minute can we process?
Are you looking at it for like the throughput or the takt time?
Well, what's claims per minute?
Takt time? No. Claims per minute would be
like a throughput measure, right?
Yeah.
Okay. So that throughput measure, then, are we looking for the highest or the lowest?
Lowest, so it would be the mailroom clerk.
So it's the mailroom clerk, right? Okay. So it's always interesting to me that, and you think about, so this is the kind of stuff that you get into when you start looking at it from this perspective. Who makes the least amount of money? What's the least expensive resource they probably have here? The mailroom clerk, right? And that's potentially the limiter on the process, right? And so you'd have to say, and again, there's all kinds of other things that are going to come into play. Are you already at capacity in terms of your mailroom clerk is busy all the time, right? And so we're going to talk about that a little bit too. But you can say, okay, if this is the case, and think about it on things where it's scaled much larger. Think about it on a surgeon, right? And what if the admissions clerk is the limiting factor, right? Those kinds of things you have to say, okay, maybe that doesn't make a lot of sense. Maybe we need to add another admissions clerk if we're at capacity, if our utilization is high, okay? So then the next question would be, how many professionals are required to achieve the capacity of, say, 80 claims per hour? Okay? So talk me through, if I were to ask you that question, and we needed to look at how many people, how many of these resources would it take to do 80 claims per hour? What would you think you might choose to do there? Any ideas? You're not going to use all the information that's up there, but you're going to use one key piece of it. What's the key piece of information that you're going to use?
The bottleneck.
Okay. So yes, but this question is actually asking across all. Okay. So if we're asking for each of these, and we need to know how many we need to do 80 claims per hour, what's the key piece of information off of there that I need to use? Is it this?
Is it the effective capacity of a resource unit?
It is. That's exactly right. Because this tells us what one resource unit can do. So if I need to convert that to what I can do for 80, how many I need for 80, that's what I'm going to use. Okay? So to do that, can I have a blank sheet of paper? So to do that, we have to come back and say, okay, well, so we have our mailroom clerk, right? So I'm going to abbreviate. We have the data entry clerk. We have the claims processor. And we have the claims supervisor. And we said the effective capacity of a resource unit is what was important. Okay, so I'm going to pull that from the table. We have 1 claim per minute for the mailroom clerk, 0.2 claims per minute for the data entry clerk, 0.13 claims per minute for the claims processor, and 0.4 claims per minute for the claims supervisor. Okay, so that being said, if I want to know how many mailroom clerks I need, right, I can say, well, I can currently do, I'm just going to do it down here. I can currently do 1 claim per minute. And the question asks us, well, how many does it take to do 80 claims per hour, right? So I would have 1 claim per minute, and I need to convert that to hours, so that's going to be times 60 minutes per hour, right? Times X number of resources, right, needs to equal 80. Okay? So it's just, you're setting up basically an algebra equation that says, well, I need to solve for how many of those I need. Okay? And so that being the case, this comes to let's go 60 claims per hour times X equals 80, and then we would go X is equal to 80 divided by 60, which tells us that we need 1.333, right? Sorry, that's a little, there. Okay, and let's just do the last one as well. Let's do the claim supervisor.
Would you have to do this for each one?
You do.
Okay.
Yeah. If the question asks you how many do you need for each one, that's what you'd have to get back to. Okay, so we're going to do the claim supervisor, and we know that the claim supervisor can do 0.4 claims per minute. And we know that we need to convert that to hours, so it's times 60 minutes per hour. And so then that becomes their effective capacity per resource unit in an hourly basis, times however many resources we need needs to equal 80. So again, it becomes 4 claims times 60 minutes, then becomes, so 0.4 claims times 60 minutes becomes 24 claims per hour times X equals 80. So X is equal to 80 divided by 24, right, which equals 3.33 claims processors. Okay, so again, it's not hard. You just have to understand how you have to set it up to be able to answer that question. Okay? I wonder. All right, so we've kind of walked through how we determine the effective capacity of a resource pool, how we would determine how many of each professional we need. And again, it's being able to look at that and understand and rationally pick out what information you need to have. Okay? All right, so we talked about how many resources we needed, and I talked a little bit about utilization, right? So which one, so we know which resource is the bottleneck. Then the question is, what's their utilization? Are they actually fully busy, or do they have some playtime in there? So throughput of a process may not equal capacity because of internal or external constraints. Okay? Let me explain what we mean by that. So throughput of a process may not equal capacity because of external constraints. Could mean you just don't have enough sales, right? You have these people and you don't have enough business to meet your capacity. Internal constraints could mean that some other department that's feeding you isn't giving you enough units to process, right? So you have to look at where is that constraint coming from. Therefore, it's important to calculate what your capacity utilization is, okay? All right, so U sub I, which is utilization for the ith unit or the ith resource pool. So it's throughput divided by effective capacity of that resource pool, okay? So let's look at utilization then, all right? And so in our example, we're going to say that a day is 8 hours long, right, and 60 minutes a day. So that means that in one day there's 480 minutes, okay? So if we're going to think about the effective capacity of a resource pool for one day, right, we're going to say, well, they should be able to process 1 claim per minute, and there's 480 minutes in the day, right? And so that means that they should have 480 claims per day, right? And in the same token, 1.6 claims per minute times 480 minutes in a day gives us 768, okay? 1.5 times 480 gives us 720, and 2 times 480 gives us 960. So that's our effective capacity of that resource pool for the day, but their actual throughput is only 400 per day, okay? So you can see that our mailroom clerk is 83% utilized, our data entry clerks are 52% utilized, our claims processors are 56% utilized, and our claims supervisors are 42% utilized. And we do that because we take this and divide it by this, right? 400 divided by 480 is 53, 400 divided by 768 is 52, right? And so you're just walking through that, trying to determine what that utilization of that resource pool is. Hunter?
So some of those are almost down to like where they're only half effective. You could like delete positions. Is that like what it's saying, or?
That would be one approach, or the other approach could be, think about in a supervisory role, that probably is not all that they're doing. So then you'd have to ask yourself, you know, what percent of the time do you think they're actually dedicated to that, right? So as a supervisor, when you're working as a supervisor, you're not doing one particular thing. And so then sometimes you have to make an adjustment with the calculations to say, right, 42% of the time, as we have two supervisors, so there's ways to adjust for that and make it legitimate, okay? One of them would be when we say that we have two claims supervisors, then you could say, but they only spend 50% of their time on this, so two claims supervisors times 50%, it's effectively one claims supervisor, right? Or on the other end, you could leave it and come out at this end and go, well, it shows 42% utilization, but they spend 50% of their time on other things, so, you know. So it's a tool to use, and you just have to know how you want to interpret it.
Was it the goal or the book that said you don't want 100% efficiency?
The goal would tell you don't want 100% efficiency,
okay.
And I would agree with that. I would agree with that.
Why is that? I mean,
because there is always uncertainty and unknown, and so if you plan for 100%, then you're making other people wait all the time, right? Because it's never an even keel. Right? If we were at 88 to 90% utilization, we were killing it in the manufacturing plant. So
is that like what you want to shoot for?
It depends on the industry. It depends on the industry. So you kind of have to know your business and know, okay, where does that come into play? Okay?
How much of that unknown you're going to get on a daily basis?
But again, in the manufacturing plant, if we were at, you know, again, that 88 to 92%, we were feeling like we were top dog. So, so again, what I want you to recognize is these are tools that you can use, but you have to know how to interpret them and what they mean, right? And so we're going to look at these examples, and we're going to make some assumptions about those examples. Like in this case, we would say, yeah, you would say, Hunter, to your point, you would say, we have one too many claims supervisors. Right? Because we could get by with if this accurately reflects what they're doing, we have one too many claims supervisors. Okay?
Why would you assume it's the claims supervisor and not one of the other positions?
Because of this, right? Because of the utilization.
I mean, yeah, I see that, but if you take them away, I guess if you're not, management side of me says, why take that one away when you could move other people around and possibly increase everybody's?
Gotcha. So So what you're saying is, as a manager, you'd look at that and say, if the mailroom clerk needs help and my data entry clerk is only 52% utilized, why wouldn't I have the data entry clerk help the mailroom clerk? That's exactly the kind of thing you're looking at when you look at this.
But sometimes you're not going to get that much input, so that's why you would look at deleting them. If you're only getting 400 claims per day on average, and you're not going to get it more, you don't want to increase.
That's right.
True too.
That's right. So then the question is, so in this case, the constraint is external because that's all the business that we have. And so then you go to your salespeople and say, we need more business, right? Which is exactly what he did in the goal. He went out and said, look, we need more business. You need to get us more volume, okay? But you can see, you can interpret this in a lot of different ways given the context of the situation, right? And so we're going to talk about things generally speaking, but the context of whatever process you're evaluating is going to drive some of your decision making, okay? But those are good questions, okay? All right, so again, what do we notice about the utilization of the bottleneck? Remember our mailroom clerk was our bottleneck? What's the deal with the utilization then?
Really high.
It's the highest utilization you've got, okay? And that should follow every time. Whatever your bottleneck is, should be your highest utilization, okay? All right, so other factors that affect effective capacity. So you assume that resources handle units sequentially or one unit at a time rather than load batches. Okay, there's a section that deals with that, but initially we're just going to be talking about they're handling them one unit at a time. We're going to assume that all resources are available for the same amount of time. So imagine a factory that has some units running on second shift, right? We could figure out how to handle that, but we're just going to assume for now that everybody's running on the same amount of time. And we've ignored the effects of setups or switching between products. So imagine an operating room that needs to be reset between different types of surgery. So these issues are addressed in Appendix 5.1. Okay, so again, for this part of the chapter, we're not going there. We're just making the most basic assumptions. So the effect of product mix on effective capacity and profitability of a process. In most organizations, sales and marketing make the product mix decisions, right? They're out in the marketplace trying to determine what products we want to sell. Since such decisions affect the process capacity, a major driver of profitability, input from the operations group, which is responsible for production, is required. Of course, we say is required in this class because we're an operations class. Okay, it's best if it works that way. So now we're moving away from where we're just talking about one type of product. Now we're going to be talking about two types of product. So when you're doing your homework, okay, make that separation. What we did in the first part of the class was if we were only dealing with one product, okay? Now we're going to be dealing with these two types of products, and we have a physician claim and a hospital claim, and they take different amounts of time, okay? So the physician claim, you can see, takes the mailroom clerk 1 minute, data entry 5 minutes, claims processor 8, claims supervisor 2.5, okay? The hospital claim takes 1.5, 6, 8, and 4. Okay, so what we need to do then in order to be able to move forward with our analysis is come up with what we would call an artificial unit load. Okay, and basically it's a weighted average depending on the volume of physician and hospital claims. You take a weighted average of the times to come up with your artificial unit load. Okay, so and I think I probably got ahead of myself in the explanation because I think it's how they go through this is they initially, so we looked at, before we were looking at the physician, right? And so now we're going to look at the hospital. And so if we look at the hospital as just a single unit, right, you bring this information down, you take the inverse of it, right? You take the number of units in the resource pool, right? And then you get the effective capacity. So does that, so here's our unit load that's given to us, the inverse of it, the number of resources, the effective capacity of the resource unit times the number of resource units in the pool gives us the effective capacity of the resource pool for hospital claims. That's identical to what we did before.
Is the number of units in the resource pool given to us, like
So-
in the problem, like the third column, or
Yes,
this
so
that's given to us?
this information is given to you and this information is
Okay.
given to you. So you'll be calculating this and this. So I'll do it on the screen for the online students. So basically, this information is given to you, and the number of units in the resource pool is given to you. So then you end up calculating the effective capacity of the resource unit and the effective capacity of the resource pool. Okay? All right. I think what I want to do is, so I started to go into what if we had two products. We're going to look at that on the next. So your homework today is just going to be about, it'll keep your mindset straight on, you're just dealing with one type of product, and it's going to be exactly what we did here. And then on next Tuesday, we'll go through, okay, well now what if we want to blend those two, and how does that work? Okay.
Which homework is that?
So this should be 5A, right, that goes with this. Right? Okay. So for the remainder of the class, if you all have any, if you want to talk about your projects or you have any questions about your projects, that's what we'll do. I'm going to go ahead and leave it there, again, because I want to segment how we walk through this. So you have a chance to do the homework for 5A before we move on to the second part of it. Right?
So we just all go through 5A and just do it here in class?
You sure can.
You lead.
I have a question about our project.
Sure.